We're going to talk about section 4.3, and we're going to talk about logarithms. And so you can answer these questions. We did these in class, but we can rewrite them. 2 raised to what is 64? 4 raised to what is 64? 5 raised to what is 1 over 125? 7 raised to what is 1? And 10 raised to what is 0? So these are all asking for what is the exponent, right? When we talk about exponential functions, we were looking at this, y equals a raised to the x, right? And if a is not equal to 1, but it can be any other all positive values, right? So when we look at this, we weren't asking, trying to find x. We were trying to find y. What's the y value given an x? So we would plug in an x value. Well, we would have some kind of a, so like this, right? And then we would get to pick the x, and then go ahead and solve for y. But here it's asking for what is the exponent. We're after the exponent. So this is basically, even though I put x's here, probably should have put y's, but that's okay. We're asking for the exponent here. On these problems, on exponential ones, we get to pick the number 4x and figure out what y is. But here we're trying to find out what the exponent is. Well, that is a form of an exponential. What actually happens is we have our normal standard exponential, but when we switch the x and y's, we get this. So here we're asking what is the exponent, right? We're always trying to find what y is, so we're trying to find what is that exponent that leads us to that x. Now this is a form of an exponential function, and you notice that I switched the x and y, so that means that these are inverses kind of each other. And this type of exponent is called a logarithm. And it's abbreviated just with log, and so that stands for logarithm. So how we write this as an expression is like this: log base a of x, and that's kind of how you say it, log with base a of x, or you can say logarithm of x with a base of a. And then there's a final way, base a logarithm of x. So that is how we can go and write the logarithm. And so by definition, it's y equals log base a of x, and I can transfer that to an exponential. So I can take the log and I can switch that to an exponential. X equals a raised to y. So that's how I solve these logarithm problems, is I switch them to an exponential in this form, and then I can answer them. Okay? And then I can also take an exponential and turn it to a log as well, and we'll do that already. So if we look at these problems, if I write these, I could write these each as logarithms. Okay? So this says log base 2 of 64. Okay, that's what number 1 is saying. Log base 2 of 64. And the answer is 6, right? The second one is log base 4 of 64. So it reads 4 raised to what is 64. This one reads log base 5 of 1 over 125. So 5 raised to what is 1 over 25? That's negative 3. This one reads log base 7 of 1. 7 raised to what is 1? That's 0, right? Log of a, base a, of 1 will always equal 0, right? Anything raised to 0 is 1. Now what about this last one? Log base 10 of 0. Can I raise 10 to anything to get 0? Well, if we look at our exponential function, looks like this, right? At 0 it's at 1, and then it goes down, 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 but does it ever cross? Does it ever cross that x or y equals 0? It doesn't, right? So there is none. This is not possible, or no solution, right? Because we have a horizontal asymptote right here. We learned that from exponential functions. Okay, so that is a logarithm. Okay, so let's go ahead and practice some. So here we go. We can go back and forth from exponential form to logarithmic form. Okay, so the arrow is going back to the left and to the right, and so we can go ahead and practice a few of these. So we want to take this exponential form and write it as logarithmic, right? So my base is my base. The base stays the base. Okay, and basically what happens is my x and y's just switch places, right? Because these are inverses of one another. My x and y's just switch places. So my y is now going to go, or actually probably just do this one, right? My y, that's over here on the log. That's what I'm taking the log of. I'm taking the log of y. It's going to become the exponent, right? So this y will come to this x, and this y will come to that x. Okay, so that means I got to take this base, leave it there, and I have a log, right? I'm switching to log, so that's my base too. And real quick, this is called a subscript, so it kind of sits below. Right here's the plane, same plane, that 2 kind of sits below. Now, my answer of the exponential becomes what I'm taking the log of, right? So that's going to go there. So my answer is 8, and then this equals my exponent 3. I might have drew this wrong here, sorry. So my y goes in this place right here, is that y. So my answer becomes what I'm taking the log of, and my exponent becomes the answer. Okay. So that's how it kind of works. I probably shouldn't have. How I should have switched these actually is should have put the x here and the y actually here, like that. So then you can see the x's and y's switch places. So that's how I should have wrote it there. Okay. So here we go. Here I'll do a couple more. Go ahead and switch this one to logarithm, or it's going from a log to exponential, so switch that to an exponential. So that is 3 raised to what? So you can just put equals x here and then x, or you can put the answer equals 27. So if you want to, you can just put the answer there, which would be 3, correct? Okay, a couple more. Here you go. 2 to the 4th we know is 16, right? Write that as a log. That is log base 2 of 16 equals 4. So basically, these two switch places, right? Those two switch places. So right now the 4 is on the same side as the 2. Well, now the 16 is going to be on the same side as the 2. So those switch places. As we can see here, 3 and 27 are on the same side. Now the 27 and the x switch places. Okay, so if they're on the same side to begin with, they're not going to be on the same side when you transfer them, because basically your x becomes your y and your y becomes your x. Alright, let's do some homework problems then. Okay, so here's your homework, page 422, number 3, 5, 7, and 9. So go ahead and you can do those ones. Here's number 5. We got 2/3 raised to the -3 is equal to 27 over 8. And what you're asked to do here is write this in, go from exponential form to logarithmic form, or from logarithm form to exponential form. Okay, so you can try this, pause the video, you can do it. Okay, so that negative is going to flip this fraction, right? So 3 over 2, now it's a positive exponent. Okay, Now we can go ahead and switch it to exponential form, right? These two are on the same side, so that means this 3 and the 27 over 8 is going to switch places. So we're writing a log. My base is 3/2, and then I'm going to switch places with the 3 and the 27/8. So this is 27/8, and this is equal to 3. Okay, you could have left it as a negative, and so it would have been log 2/3 is 27 over 8 equals -3. And that's probably the way it is in the back of the book, is probably that one. So you probably I shouldn't have switched the negative there, but that's okay. Okay, I think I skipped number 3, so here's number 3. You can go ahead and do that one. So we're switching to the log. So what's my base? 3, and then 3, and then 3 raised to what? 4 equals 81. So the 4 and the 81 switched places. Okay, so that's the answer to that. Okay, so now you're switching this to an exponential. So 6 raised to what equals 36. 6 squared equals 36. There, it's an exponential. Okay, number 9. Log root 3 with base root 3 of 81. So log base root 3 of 81 is equal to 8. So rewrite this in exponential. Root 3 raised to what equals 81. So root 3 raised to the 8 equals 81.